All right, everyone, welcome back to our discussion of some mathematics here as we're working our way into dealing with physics problems with motion and stuff. First off, let's talk what a system of equations was. Realistically, it's a group of equations that are all true at once, and we're trying to figure out the solution for all of them. Where do these equations meet? Mostly, we're going to be focused on two equation systems, but there are larger systems out there. We talked about solving by graphing last time, which really amounted to we put two lines on the same graph and we asked ourselves, where do they meet? And ultimately, they'd either meet at a point, they would be the same line and meet at all the points, or they'd be parallel lines and they would never ever meet. Okay. So graphing as a method, it's there. I don't know how many people seriously use graphing when they're dealing with these in the real world. You probably wouldn't, unless there was some weird reason that you did. Most people use some sort of algebraic method to solve these. So really, graphing is good to get a review of graphing, and it's good to kind of visually see what's going on, because algebra can sometimes be very abstract to people. But ultimately, you wouldn't really use graphing for systems of equations, especially in physics problems, because we often deal with weird numbers. We're often talking about numbers that are big or really small, and you just wouldn't want to use graphs. It would be very annoying and cumbersome. So instead, we have other methods. Today's method we're going to talk about is substitution. And let's say we have these two equations here, and ultimately, I've got x plus y is 6. I've got x is y plus 2. So x is y plus 2. Okay? I can replace x with y plus 2 whenever I want. So I can take the second equation, x equals y plus 2, and I can literally substitute it into the first equation. So if I replace x in the first equation with y plus 2, I've used the substitution method. And now I would end up with y plus 2 plus y equals 6. Now it's really important that you recognize that I use these parentheses. There are many situations where you're not just plugging into x, you're plugging into 2x or 3x or 5x. And we're going to have to distribute across all the terms. So I start off with this inside parentheses to kind of recognize that ultimately there may be distribution that occurs. In this case, there is none. So the parentheses can come off. That's easy. I've got y plus 2 plus y, so that's really 2y plus 2. I need to isolate my variables, so I'm going to subtract the 2 off. That's going to give me 2y equals 4. And then I need to get y by itself, so I'm going to divide by the 2 and find that y itself is 2. Now, check it. There's two variables. The key to solving a system of equations is really to get rid of one of the variables. That's all the stuff that we do when we're trying to do the algebra, because you can't solve both variables at the same time. So you solve for one, in this case by replacing it with by replacing the other with the other equation, right? So we get rid of one of the variables. We got rid of x in this case. And we were able to solve for y because there were no x's around. It actually becomes a really easy problem. 2y plus 2 equals 6 really isn't that hard. Okay? You've done much harder problems, I'm sure. Now, we know what y is, but we don't know what x is. So we need to go back, and we can actually go back to either of the original equations, and we can solve for the x. Okay? And you're going to solve for x by plugging in that 2 for y. So here I took the second equation, x equals y plus 2. I'm going to plug in the 2 for y, and I got 2 plus 2, which is really just 4. And the solution in this case is 4, 2. You could also have a situation where you have both of them set equal to something. In this case, they're both set equal to y. Y equals negative 3x and y equals 10 minus 4x. This is going to happen whenever they're in y equals mx plus b format. So we've got them already set up so that y is stuff and y is stuff. So you can actually use substitution to substitute one equation for the other. We actually call this equal values method in your math book. It literally is a special case of substitution wherein both equations happen to be in the slope-intercept format. They're both solved for y, so I can literally make negative 3x equal to 10 minus 4x. That's what I'm going to do here. And now I've got negative 3x equals 10 minus 4x. So I need to solve this so that there's just x. So I got negative 4x, I got negative 3x. I moved the 4x over, and then I got x is 10. But you're not done. You got to take the solution for this, and you need to solve for the y. So y is negative 3x there. I'm going to plug in for the 10. 10 times negative 3 gives me negative 30, and my solution is 10 negative 30. All right, here we got another equation. We got x minus y is negative 3. We got 2x plus 3y is negative 6. Neither of these are in a really easy format to use something like equal values. But if you notice, that top one is x minus y equals negative 3. So I could really easily solve that one for x. I'm going to take that equation. I'm going to move the y over. I got x equals y minus 3. Awesome. Now I'm going to take that and I'm going to plug it into the second equation. I'm going to plug in y minus 3 wherever I see it, and I got to distribute that 2. Now remember that when you distribute the 2 times the negative 3 gives you negative 6. Okay, the sign hangs out with that negative 3. You got to be careful when you distribute, because a lot of people make mistakes with negative signs. It's very common. All right, combine like terms. Move your constants over, and then you get 5y is nothing, so that means that y itself is nothing. If y is nothing, then I can go back in, I can solve for x. I plug in 0 for y. 0 minus 3 is still negative 3, and there's my solution, negative 3, 0. That's really about it. As far as these problems go, you literally plug one equation in for the other, and you got to remember to go back and solve for the first equation or the other variable. Otherwise, you only have half the answer and you get about half the credit. Okay, so watch yourself, go slow, and remember that you need to do both variables or it's not complete. All right, guys, have a great night, and I'll see you in class tomorrow. Bye.